Welcome to Geekloka Technology Tutorial. Today in this video we will learn about bubble sort algorithm. Let's get started. Bubble sort is a simple sorting algorithm that repeatedly steps through the list to be sorted, compares each pair of adjacent items and swaps them if they are in the wrong order, and repeat it until no swaps are needed, which means the list is sorted. Picture these 5 selling boats numbered 90, 80, 60, 70, and 50 are lined up for a unique challenge. Their tasks to arrange themselves in ascending order, mimicking the steps of bubble sort. As we begin, the boats are in this order: 90, 80, 60, 70, and 50. Just like bubble sort, they will compare their numbers and rearrange accordingly. First iteration, the boats start comparing. The boat 90 and boat 80, since 90 is greater, they swap places. Our lineup is now 80, 90, 60, 70, and 50. Boat 90 then compares with boat 60, again a swap. The sequence changes to 80, 60, 90, 70, and 50. This process of comparison and swapping continues. 90 swaps with 70 and then with 50. The largest boat, 90, has found its way to the end, just like the largest bubble rising in the water. Second iteration, the boats are now 80, 60, 70, 50, 90. Starting again, 80 swaps with 60, then with 70, and finally with 50. The order after the second iteration is 60, 70, 50, 80, and 90. Third iteration, the fleets now reach 60, 70, 50, 80, and 90. Both 60 stays put as it smaller than 70, but 70 and 50 swap, bringing our arrangement to 60, 50, 70, 80, and 90. Fourth iteration, it's time for the final touches. Both 60 and 50 swap. And there you have it. The boats are now in the perfect order: 50, 60, 70, 80, and 90. Each boat has gracefully sailed to its rightful position. Through the maritime adventure, we have seen how bubble sort, much like our fleet of boats, rearranges elements through simple steps. Each round, the largest unsorted boat advances toward its correct position in sorted order, eventually leading to a beautifully organized lineup. And now we are diving into a live detailed simulation of bubble sort using an array of 5 elements: 90, 80, 60, 70, and 50. Let's see how bubble sort bring order to this numerical chaos one step at a time. Picture our array: 90, 80, 60, 70, and 50. We will sort it in ascending order over 4 iterations. Each iteration will bubble up the largest number to its correct position. First iteration, we start by comparing the first two elements, 90 and 80. Is 90 less than 80? No, it's larger. So, we swap them. Our array now looks like 80, 90, 60, 70, and 50. Next, compare 90 and 60. Again, a swap is needed. The array changes to 80, 60, 90, 70, and 50. We continue this process: 90 and 70 swap. Then, 90 and 50 swap. At the end of this iteration, the array is 80, 60, 70, 50, and 90. The largest number 90 has reached its final position. Second iteration, we now ignore the last element 90 as it's already in place. Starting again, we compare 80 and 60, then 80 and 70, and finally 80 and 50, swapping each time. The array after this iteration is 60, 70, 50, 80, and 90. Third iteration, our focus is now on the first three elements. We compare 60 and 70, no swap needed. But 70 and 50 need to swap. Our array now reads 60, 50, 70, 80, and 90. Fourth iteration, we are almost there. We compare the first two elements 60 and 50 and swap them. Our final array is now neatly sorted 50, 60, 70, 80, and 90. And there you have it. Over 4 iterations, Bubble Sort has successfully sorted our array. Each iteration effectively moves the largest unsorted number to its correct position, just like bubbles rising to the surface of water. Now, let's see the illustration code. The core of Bubble Sort lies in two nested loops. The outer loop, controlled by I, runs from the start of the array, but stops one element before the end on each iteration. This is because, after each complete pass through the array, the largest number is already in its correct position at the end. Then, let's focus on the optimization part, the size minus I minus 1 in the inner loop. Here is where the algorithm saves time. On each pass, as the largest number settle at the end, we don't need compare them again. So, the range of comparison reduces with each iteration. After the first pass, the last element is sorted. After the second, the last two are sorted, and so on. Therefore, size minus I minus 1 ensure the inner loop only goes as far as it needs, avoiding unnecessary comparisons. This tweak, while seemingly small, significantly improves efficiency, especially as the size of the array increases. Through each iteration, the algorithm compares and swaps adjacent elements. Larger number bubble up to their correct positions, and eventually the entire array is sorted in ascending order. This is the end of this video. Thank you for watching Geekloka channel. Don't forget to subscribe and see you on next tutorial.